It is a landscape defined by its thirst. Yet here an ocean has been tamed to make the desert bloom. Amid the harsh expanse of the Middle East, a place of rock, wind, and burning sun, the nation of Israel accomplished a feat of staggering ambition. A massive artificial river was carved through the sand, a network of canals stretching over 12,000 kilometers long. Through this system, billions of liters of water were channeled from the Mediterranean Sea, a lifeline drawn across an arid land. But this was only the beginning of the transformation. The true marvel lay not just in moving the water, but in remaking it entirely. Inside colossal desalination plants, cutting-edge technology was put to work, turning the endless supply of salt water into fresh, clean, drinkable water. This is the story of how one of the most extraordinary engineering feats of our time unfolds. One landscape was defined by endless thirst, the other by an ocean of undrinkable water. For generations, the Negev desert in southern Israel was a dead land, its earth a cracked mosaic seemingly impossible to cultivate. Summer temperatures would climb above 110 degrees Fahrenheit, while rain offered only a few weeks of brief relief each year. Deep below the surface, the underground aquifers were steadily shrinking, a crisis worsening with every passing generation. Agriculture, the very backbone of the young nation, was pushed to the verge of collapse, forcing many families to depend on water hauled by truck from far-off regions. Yet just a few dozen miles from this unforgiving terrain lay the Mediterranean Sea, vast and shimmering with salt water. This profound contrast sparked Israel's most daring vision, to pull the ocean inland, deep into the heart of the sand. The Desert Water Project was formally approved in the year 2000, fueled by an investment of nearly $3 billion. With this monumental commitment, the goal was not merely to turn salt water into life, but to challenge the desert itself and command new rivers to flow. A foundation of shifting sand must first be made as solid as rock. Before any water could flow, the very desert itself had to be tamed, transforming a barren, windswept wilderness into a stable platform for construction. The process began from above, with high-resolution satellite imagery and ground-penetrating radar charting the restless dunes. Thousands of wind measurements helped identify the few stable corridors safe enough for the immense project. For months, survey teams lived in the heart of the Negev, drilling hundreds of boreholes more than 100 feet deep to reveal the hidden geology beneath the sand. Every route marker was positioned by hand, its location recorded with centimeter-level accuracy. The entire canal path was meticulously planned to avoid the treacherous wind corridors where a single sandstorm could bury the worksite overnight. Fleets of bulldozers were then deployed to level the landscape, carving down the high ridges and shifting sand into the valleys below. The objective was to forge a smooth, balanced surface, strong enough to bear the weight of heavy machinery without collapsing. Surveyors supervised every section, checking the elevation and slope to ensure perfect uniformity across miles of open desert. Conveyor systems carried excess sand away from the work zone, while compactors gently firmed the top layer into a workable base. But even after the dunes were flattened, the sand remained unstable. Engineers discovered that injecting water into the loose surface could bind the grains together, creating a denser, more cohesive layer. Long sprinkler arms and underground pipes delivered controlled amounts of groundwater, allowing moisture to seep several inches deep. Once the sand achieved the ideal dampness, heavy rollers moved in. The constant rumble of steel drums echoed across the desert, with each pass compacting the surface, removing air pockets and locking the particles together. As the sun baked the surface dry, the soft, shifting ground hardened into a solid foundation, built from nothing more than sand and water. The desert floor began to yield, not to the wind, but to the unyielding will of steel. An army of excavators and colossal dump trucks roared to life, embarking on one of modern Israel's most ambitious earth-moving projects. Each day, the Negev desert surrendered some 70,000 tons of sand and soil, gouged from a construction corridor that snaked for nearly 250 miles. A workforce of over 1,200 engineers, operators, and laborers toiled in relentless shifts, battling daytime temperatures that frequently soared past 115 degrees Fahrenheit. The channel itself took shape as a broad U-profile, spanning about 150 feet at its base, with an average depth of 23 feet. To ensure water could flow by gravity alone, engineers maintained a longitudinal slope within a razor-thin margin of just 1 inch for every 100 feet. To hold this line, survey crews constantly rechecked the elevation, using laser leveling instruments every 160 feet to guarantee the canal floor remained perfectly true. The vast quantities of excavated sand were repurposed to build up the embankments on either side, creating protective levees 10 to 16 feet high. Where the land rose into hills, bulldozers carved down in step layers. In low-lying areas, convoys of trucks hauled and stabilized fill material until the precise grade was met. In zones of weak soil, engineers drilled 16-inch sand piles to depths of 20 to 25 feet or mixed cement and clay to fortify the base against subsidence. Stretching for hundreds of miles, the construction sites were dotted with concrete batching plants, mechanical workshops, and field engineer camps. Under the scorching sun and swirling dust, long convoys of trucks and machines moved endlessly, a mechanical river carving the shape of a real one into the heart of the Negev. The desert has a thirst that can swallow rivers whole. To defy it, engineers would have to build a fortress of concrete and ingenuity. Deep in the heart of the Negev, where the sand could absorb any exposed water in mere hours, the lining of the canal became the project's most critical phase. The solution was a meticulous process of sealing the earth against its own relentless dryness. First, the raw canal bed and its sloping sides were carefully dampened, then smoothed over with a 2-inch layer of fine sand, creating a uniform canvas. Over this foundation, concrete panels were poured, each one a solid slab 4 to 5 inches thick. These sections, measuring 16 feet long by 10 feet wide, were laid one after another, separated by crucial expansion joints. Each gap was then meticulously filled with hot bitumen sealant, a dark, viscous material designed to prevent any leakage, while allowing the concrete to shift with the desert's extreme temperatures. Where the subsoil proved unstable, an extra layer of defense was required. A high-density geomembrane was laid beneath the concrete, secured with steel anchors and shielded by a protective cushion of sand. In total, more than 220 miles of the canal were encased in concrete, forming one of the most extensive waterproofing systems ever constructed in the Middle East. Along the embankments, engineers planted hardy vetiver grass and desert acacia to stabilize the slopes and combat the ever-present drift of sand. From above, the canal began to look like a shimmering silver ribbon, a concrete artery waiting to carry its first life-giving pulse through a sea of gold. A river cannot be tamed by a simple ditch alone. To command its flow across a desert requires an intricate network of hundreds of supporting structures, each designed for transportation, flood control, and the precise regulation of water. The journey begins at the town's sub-barrage, where a massive head regulator diverts water from the mighty Indus River. Here, engineers from WAPTA installed 9 colossal steel gates, the very first point of control for the entire system. From this origin, the main canal stretches out, incorporating more than 900 distinct engineering components along its path. This complex web includes reinforced concrete bridges, spillways, siphons, drainage culverts, and aqueducts that lift the canal's flow over natural streams. Wherever the channel intersects a road or railway, a new bridge rises to ensure traffic continues uninterrupted. In sections that traverse existing waterways, great cross-drainage structures are installed, forming large conduits that allow the natural flow to pass safely beneath the artificial canal. Further downstream, distribution gates appear every 6 to 9 miles, meticulously managing the flow into a network of secondary branches. Every single component must operate in perfect harmony. A malfunction at just one gate, or a failure at a single aqueduct, could instantly deprive hundreds of hectares of precious farmland of the water they depend upon to survive. For 15 years, the desert had only known dust. Now it would learn the sound of a river. Following more than 15 years of relentless construction, the Colossal Canal at last reached its crucial water testing phase. At the town of Sabaraj, engineers eased open the gates, allowing the Indus River to surge into the channel section by section. The discharge was meticulously increased, first to 500, then 2,000, and finally 6,000 cusecs. Along the entire route, technical teams moved with precision, inspecting every critical point. They measured pressure, scoured the structure for leaks, and monitored the stability of the canal slopes, carefully recording even the slightest ground movement. Any deviation was immediately corrected before the system was brought to its full operational capacity. When the first rush of water finally carved its path through the cracked, dry canal bed, the regions of Darabukti and Yalmagsi erupted. The people called it the day the desert came back to life, a moment when cheers followed the water wherever it reached. This was not merely a flow of water, it was a current of hope, the fulfillment of a dream that generations of farmers had waited their entire lives to witness. The desert finally tastes the sea, but this gift is a poison in disguise. Water from the Mediterranean courses through an artificial river, a blue scar across the arid land, yet it remains untamed. In this landscape, salt can be a greater threat than drought itself. Before this water can sustain millions, it must navigate an intelligent desalination system, a technological artery stretching from the coast deep into the heart of the country. Here, the seawater undergoes a meticulous purification, passing through mechanical filters, settling tanks for sand and oil separators. The final transformation happens through nanofiltration and reverse osmosis, where every molecule of salt is stripped away, leaving behind nothing but pure, life-giving water. A network of digital sensors stands guard, constantly measuring salinity, pressure, and flow. The system automatically adjusts its own parameters, ensuring the highest standards of purity are met without fail. Only after clearing these layers of control is the water released into the main canal, beginning a journey of hundreds of miles across the Negev desert. It is no longer seawater, but a true lifeline forged from hope and ingenuity. Even after the initial pre-treatment has removed large debris and sediments, the water still teems with fine particles and microscopic organisms. To protect the delicate technology that lies ahead, a crucial stage of fine filtration is introduced. Inside colossal filtration tanks, arrays of black hollow fiber membranes act as impossibly thin barriers, intercepting algae, bacteria, and the smallest remaining solids. The most decisive phase, however, unfolds within the reverse osmosis system. Under immense pressure, the seawater is forced against semi-permeable membranes, their pores hundreds of times smaller than a human hair. This invisible wall permits only pure water molecules to pass, trapping salts, heavy metals, and trace chemicals on the other side. High-pressure pumps generate tens of bars of compression, transforming the murky, saline liquid into a pristine stream. Yet, as it emerges from the reverse osmosis modules, the water is so pure it has become almost sterile, an emptiness that must be corrected. Precise dosing systems carefully add small amounts of calcium and magnesium, rebalancing its pH and restoring a clean, natural taste. From there, the water moves to disinfection, where ultraviolet light or ozone neutralizes any surviving microorganisms, while a trace of chlorine guarantees its safety as it travels through the pipelines. Every parameter is tracked in real time, and laboratory samples are analyzed around the clock. Only when all standards are met is the water finally pumped from vast storage tanks into the distribution network. It flows through miles of underground pipes to reach homes, hospitals, and factories. A complete cycle where the salt of the ocean is transformed into a safe, drinkable resource. A testament to the remarkable power of modern engineering. Where the sun had scorched the earth to dust, a new kind of river was about to flow. As the first currents of engineered water reached the Negev desert, the transformation was immediate and profound, touching not just the land, but the very fabric of life itself. Parched earth, once fractured by relentless heat, began to breathe again. Families who had abandoned their homes to drought slowly returned, their tents and stakes marking the first new beginnings on the sand and stone. From the primary artery of the national water carrier, a web of secondary canals and pressure pipes branched out. This network fed drip irrigation systems, a pioneering Israeli technology designed to deliver life-giving water directly to the root of each plant, conserving every precious drop. The monumental effort began in 1953 and spanned over 11 years, with a final cost of around 420 million Israeli lira, a sum equivalent to hundreds of millions of dollars at the time. Once complete, the system pulsed with a capacity of 72,000 cubic meters of water per hour, a constant flow from the fertile north to the arid south. As a result, landscapes once written off as barren wastes awakened into vibrant agricultural hubs. In those early years, tens of thousands of acres of farmland were reborn in green. Where only dust had danced in the wind, groves of oranges, sprawling vineyards, and fields of wheat now stood. From orbit, the change is stark, a long, verdant ribbon winding its way across the golden expanse of the desert. This green artery, this artificial lifeline, stitched the countries north and south together. The renewal, however, went far beyond the fields. Villages were rebuilt from the ground up, schools opened their doors to a new generation, and high-tech farms rose from the ancient sands. Where once there was only sand, now flows a river born of the sea. It is a story of ambition on a scale that is difficult to comprehend. Billions of tons of earth were moved, meticulously excavated from the heart of the desert to carve a path for this unprecedented waterway. At its core, this monumental feat of engineering was powered by an equally audacious technology: the ability to strip the salt from the sea, transforming vast quantities of ocean water into life-giving fresh water.